How does Google Maps actually work? You type a destination, tap directions, and within seconds it gives you a route, an ETA, traffic conditions, and sometimes even reroutes you while you're driving. There are a lot of systems working together to make that happen. Let's start with the map itself. Google Maps does not download the entire planet to your phone. That would be ridiculous. Instead, the world is divided into small map tiles. When you move around the map, your phone only downloads the tiles you actually need. Zoom in, and it loads more detailed tiles. Zoom out, and it switches to lower detail versions. That's why the map feels infinite even though only a tiny part of it is loaded at any moment. Now let's say you search for a restaurant. Google needs to understand what place you mean. That means searching through a huge database of businesses, streets, landmarks, addresses, and geographic coordinates. Once it finds the place, it converts that location into latitude and longitude. Now you tap directions. At this point, Google Maps can model roads like a giant graph. Intersections become nodes. Road segments become edges connecting those nodes, and every edge has a cost. Maybe distance, maybe expected travel time, maybe tolls, maybe whether the road is closed. Now Google needs to find a good path from your location to your destination. This is basically a shortest path problem. Algorithms related to Dijkstra's algorithm or A** can search through the road network and find efficient routes without checking every possible road on Earth. But finding the shortest route is only part of the problem. You probably want the fastest route, and that changes constantly because of traffic. So where does traffic data come from? A huge amount of it comes from devices moving through the road network. If thousands of phones are traveling down the same highway at 20 kilometers per hour when they would normally be doing 100, that's a strong signal that traffic is bad. Google can combine aggregated location data with historical traffic patterns, road incidents, construction, and other signals to estimate how fast each road is currently moving. Those estimates become part of the cost of each road segment. So a route that was fastest 10 minutes ago might no longer be fastest now. That's why Maps can suddenly tell you faster route available. It recalculates using updated conditions. Now what about the blue dot showing your location? Your phone can estimate its position using GPS satellites, but GPS isn't always perfect. Inside cities, buildings can reflect or block satellite signals, so phones can also combine GPS with Wi-Fi networks, cell towers, motion sensors, and other signals to improve the estimate. This is called sensor fusion, and Google Maps has another huge problem. The real world keeps changing. Roads open, roads close, businesses move, new buildings appear, speed limits change. So the map itself has to be constantly updated using satellite imagery, street view, government data, business information, user reports, and other sources. So if we simplify Google Maps, it's really several systems working together. Map tiles render the world. Search finds places. A graph represents the road network. Routing algorithms find paths. Traffic systems continuously update the cost of those paths. And your phone keeps estimating where you are. The impressive part isn't showing a map. It's turning a constantly changing planet into a graph. Your phone can search in a fraction of a second.